Okay, thank you, Kim, for reminding this. So now, what is hub in networking? So as I said, this networking devices is any hardware component that facilitate the communications between different devices in a network. And all these devices help in data transmissions, network security, traffic management, and connectivity. So the first device is hub, which is a basic network device that connects a multiple devices in a local area network and facilitate the communications between them. And this operates in the layer one of this OSI model, which we like read in our upcoming sessions. And you can say it simply broadcast data to all the connected devices without any intelligence. But we have three different kind of hubs. The first, we have the passive hub, means it simply connects a multiple devices without processing the signal. Even it does not amplify or regenerate the data signals. Second, we have active hub, means it do the functions like a passive hub, but also amplifies and regenerate the signals. But for these things, it requires a power signal, a power source, you can say. And now most of the company are using this intelligent hub, or you can say smart hub. So it has the management features, such as with the help of this, you can also monitor the traffic, and it can detect and isolate the network issue. Means if we talk about like how a hub work, so first of all, when a broadcast data or device sends data to a hub, the hub broadcasts it to all other connected devices. Means suppose this is a device, and with this device, two more devices is connected with this hub. So this try to send the data to all the devices connected with this hub. But only the intended recipient process the data and other discard it. And this methods creates a collision of domains, reducing the efficiency in high traffic network. And it comes with lots of disadvantage. Like the first, no filtering, means it cannot determine the destinations of data. Second, high collision rate, means all devices shares the same bandwidth, leading to the network slowdowns. And the third is security risk, means since data is broadcasted to all devices, it is easier for attackers to eavesdrop. But now we have switches also, which is the advanced version of this hub. Okay. But the question is, where is the hub used? So a small network with minimum traffic and temporary setup for network testing or diagnostic, and for educational and experimental environments. So this one is all about the hub. Now, The next part. The next is repeater. This repeater also do the same thing, but this operate with the layer 1 of the OSI model, which is a physical layer. And here, its primary function is to regenerate and amplify the work and also amplify the weak or distorted network signals to extend the range of a network. So first of all, it receives or weak and corrupted signals from a network cables or wireless transmissions. It amplifies and reshapes the signals to restore its original strength and quality. And the strength signals is then retransmitted to the next segment of the network. Again, we have lots of different repeaters. Like the first we have analog. Repeaters means it amplifies the entire incoming signals, including noise and distortions. Second, digital repeater means it actually regenerates and reconstruct the original signals and filtering out the noise. Then the third, Wi-Fi repeater means it extends the range of wireless network by retransmitting the Wi-Fi signals. And the fourth is optical repeater means used in fiber optics network to boost light signals over long distances. Now let's talk about the advantage and disadvantage of this repeater. So I write the point here for this advantages of this repeater. So the first is extends network range. Means it helps the signals travel over the long distances without degradations. Second, it improves the signal quality. Means digital repeaters removes noise and distortions. And the third is cost effective. Means it is simple and inexpensive solutions for boosting the network signals. But yeah, it also comes with some disadvantage. Like the first, it cannot filter the traffic, means it forwards all signals, including the unnecessary noise. Second, no intelligent processing, means unlike switches or router, repeater do not analyze data packet. And third, limited number of connections, means only useful in simple network extension. But again, the question is, where is the repeater used? So to extend the range of wired connections, we use this thing. or to boost the wireless coverage in large home and offices. Even some optic fiber communications is also there, means to maintain the signal's strength over long distances, or radio and TV broadcasting, means to relay signals over the wide area. Is it clear now, Kim?
Yes, it is clear.
Okay. So, Kim, you work for any company or only like you are studying all these things?
I am studying and hopefully I will be able to get into this business.
Wow, nice. That's nice. So already it means you have the experience in working.
Working, yes, but not in the technology field.
Okay, in technologies field. That's nice. Now, let's study with the next part. So now the next we have bridge. See, bridge is a very important things to understand. Okay. And this is very important networking devices also. Means a bridge is networking devices that operate this time layer 2, which is the data link layer of the OSI models. Even I think I'll also teach you about this OSI model in our today's sessions only. And its main function is to connect and filter traffic between two or more network segments and reducing the congestions and improving efficiency. So, how does a bridge work? First, it receives the data frames, or better, I could write the things of this working of this bridge. So, the first is receives data frames. Means a bridge receives data from one network segments and then it analyzes the MAC address. Means it examines the MAC address in each frame to determine the destinations and then it forwards or block the frame. Means if the destinations is within the same segment, the frame is blocked, means not forwarded. And if the destination is on a different segments, the frame is forwarded to that segments only. And then fourth, it learns a network addresses. Means bridges actually maintain a table of MAC address to improve the efficiency over time. Now maybe you'll ask some questions about the MAC address. So MAC address is also known as a physical address, okay, or media access control, and it is a unique identifier assigned to a network interface controller or other network devices for communications on a network. Okay, but practically I'll teach you about this thing. Now, if we go through the types of bridges, then we have three different types of bridge. The first, we have transparent bridge, means it learns MAC address automatically and forwards the frame based on that. Then it does not modify the data packets and commonly used in this Ethernet network. Second is source routing bridge. Means this one is used in token ring network and determine the best path for a packet using the routing information. And the third we have this translation bridge. Means it converts the frame between the different network types like Ethernet to token ring. Now, again, it comes with some advantage and disadvantage. So first, let's discuss about this advantage. So first is it reduces the network traffic. Means it prevents unnecessary data from being sent to all devices. Second, it improves performance when segments network reducing collisions and congestions and also enhances the security. Means it limits the broadcast domains, reducing the exposure to security threat. But it comes with some disadvantage also. Means slower than switches, SWITCHES, yeah. Means since it examines each frame, it introduces slight delay, then limited scalability. Means these are not idle for very large networks and no advanced features. Means unlike router, bridge do not support IP addressing or path selections. Okay, so we use this bridge from small to medium network, like to connect to LAN while filtering the traffic, in Wi-Fi network to connect a wired and wireless network, and some network segmentations. Means sometimes to improve the performance by reducing the collision. Now, anyone, any questions up to here?
No questions.
No questions.
Abrar, Parishit?
I'm okay.
Okay. What about you, Abrar? Okay. The next part. Switch. So a switch is a networking devices. This time, this also operate within the data link layer. Means you can say layer 2 of the OSI model. So it connects a multiple devices within a local area network and efficiently manages the data traffic by forwarding the data only to the intended recipient instead of broadcasting it to all devices. Means how does this switch work? So the first means um, yeah, it receives data frames. Means when a device sends data, the switch captures the frame. Second, examines the MAC addresses. Means it checks the source and destination's MAC address in the frame. Third, it maintains a MAC address tables. Means it learns which device is connected to which port. And the fourth, forwards data efficiently. Means instead of broadcasting to all devices, it sends data only to the current correct destinations. And we have lots of different type of switches. Some I know, but uh, some I forget also. So the first is unmanaged switch. Means like it comes with plug and play activities with no any configurations needed. And this one is suitable for a small office, a small home network like this. Second is managed switch. Means it offers features like VLAN, port mirroring, and network monitoring. And basically, most of company and enterprise network use these things for better control and security. And two more switches were there. Mm, the third one is PoE, means power over like Ethernet, ETHERNET. Yeah, means it supplies the power to connected devices like IP camera and voice over protocol phone. Means we have some phone which comes with the features to call to the other devices with the features of IP address connectivity. Now, advantage and disadvantage. So let me first check whether we have some different type of switches or not. Unmanaged,
Can you repeat
managed.
can you repeat what was the third type of switch?
That is PoE. Okay,
PoE.
means
Thank you.
yeah, power over Ethernet switch. Yeah, thank you. Okay, that switch is not given here. Only two things are there: managed and unmanaged. But PoE is also there. Now, yeah, advantage and disadvantage. So the first is it provide the efficient data transmission. Means it reduces the unnecessary traffic by filtering data only to be intended device. Then reduces this collisions. Means each device gets a dedicated communications path. Then increases network speed. Means it supports the full duplex communications and allowing the simultaneous sending and receiving of the data, and also support the VLANs, means enhances the security and traffic management. See, these are the IP phone which helps to maintain the voice over internet protocol. Okay. Now, disadvantage. First, higher cost. Means more expensive than the previous devices like hubs and bridges. Then more complex configuration. Means managed switches requires a network expertise. Third, limited by broadcast traffic. Means this one is still vulnerable to broadcast storms if not properly configured. So where we use this switch? First, home and office network. So to connect like computer, printer, and other devices. Then in data center, means to manage a large amount of network traffic. Then in some enterprises network, means to create a virtual LAN for better traffic control. And sometimes on campus network, means to interconnect departments while managing the network access. Now you can take the screenshot. Now, router. See, most of you already knew about these routers. So you can see in this picture, like internet is coming to this modem and this router is trying to connect all the devices within the network. Means a router is a networking devices that operates at the layer 3 of the OSI model. Layer 3 means network layer. And it is responsible for directing the data packets between the different networks, such as between the home network and the internet. Means the router actually used the IP address to determine the best path for data transmission. So how does the router work? Hence, the first, it receives the data packet. Means the router gets data packet from one network and then examines the IP address. Means it checks the source and destination's IP address in the packet. Then it determines the best route. Means using routing tables and protocol, it selects the best path to the destinations. And then last, it forwards the packet. Means it sends the data to next router or the final like destinations, you can say. And again, we have lots of different type of route. Like the first, like we have this wired route. Means it connects the devices using the Ethernet cables and used in home and office networks for stable connections. Second is wireless router, means Wi-Fi router, you can say. So it provides internet access through the Wi-Fi. And this one is common in home, offices, and public spaces. And the third, we have this core router, means it provides the high performance router used in the large network like ISP and the data center, and it handles the massive data traffic efficiently. And fourth is edge routers, means it connects a local network to an external network like the ISP and optimized for fast internet access and security. Now, let's talk about advantage and disadvantage. So the first is efficient traffic management. Means it uses the intelligent routing to send data via the best path. And also it supports this multiple networks. Means it connects the different networks such as LAN and WAN, and also improves the security. Means it can include the firewall and other kind of devices like NAT to protect the devices. And now it also support a wireless connectivity. Means it provides the internet access without the cables. Means in short, you can say a Wi-Fi. Now, disadvantage. So the first is its higher cost. So more expensive than the switches and hub. Second is slower than switches. Means it processes the IP address, which takes more time than direct MAC address forwarding. And it comes with a complex configurations. Means requires knowledge of routing protocols and network setting. So where we use this router? Of course, in home network, because it's connected multiple devices to the internet. Then in enterprises network, where this manage the WAN connections and internet network segmentations. In ISP, means internet service provider, means it routes data between the global network and some data center and cloud networks. Means used for secure and efficient data transmissions. So this one is about the network. You can take the screenshot. Router. Yeah. Now, gateway. So you can see here, it is trying to connect a two different network that use a different communications protocol. Means gateway actually translate the data format, the protocol, and address scheme to enable the communications between the dissimilar system. Means suppose Parikshit have their own network and Mohammed have their own, but now they both want to connect the entire devices to each other. But here, no need to change any topologies or any kind of connectivity or protocol. You can do the same activities and connections with the help of this gateway. Okay. So how does the gateway work? So first, it receives the data packets. Means the gateway gets data from one network, then translates the protocols, means convert data format and protocols like IP version 4 to IP version 6, means TCP IP, all this kind of protocol, which we'll discuss in our coming classes. And also routes the data, means determine the best path and forward data to the next network. And also ensures the compatibility, means it is like it acts as an interface between the different communications standard. And again, now we have lots of different types of gateway. Example, obviously, network display or network gateway, sorry, means it connects to different networks such as the LAN and internet like the WAN. And a router with NAT means network address translation is a common example. Then as I said, VoIP gateway means voice over internet protocol, means actually this VoIP gateway means what? Like it converts the data packet between a traditional phone call or network to a digital VoIP system. Then now you can also add cloud gateway, means bridges on premises network with cloud services like AWS, Azure, and Google Cloud. Then IoT gateway means it connects the IoT devices with different communications protocol to the internet. And last, email gateway means it filters, scan, and protects the email from spam and malware. Now, what are the advantages? So the first advantage is it enables the communication between the different networks, means bridges dissimilar the system. Also, it enhance the security, means it acts as a checkpoint for data filtering and protections, and also support the multiple protocols, means it convert the data between formats like IP version 4 and IP version 6, and also control the network traffic, means helps in managing and optimizing the data flow. And if we go through the disadvantage, so the first is higher cost, means more expensive than router and switches. Then slower processing. So due to the protocol conversions, this gateway can introduce latency and also complex configurations, means requires a technical expertise to set up and maintain. So again, we use these things for enterprise networking, means to connect internal systems with the cloud platform, then telecom network, means for voice and data communication, for data center to integrate a different network architecture, and security system. Means as a firewall, which is our in the topic, a proxy server to filter and monitor the data and the traffic. You can take the screenshots now. Okay, now the next point is about firewall. Means a firewall is a network security device or software that monitor and control incoming and outgoing traffic based on the predefined security rules. And it like act as a barrier between the trusted internal network like the LAN and untrusted external network like the internet. Hence to prevent unauthorized access and the cyber threats. But this time this work under I think layer 3 network layer of the OSI model, but can extend up to the layer 7, which is applications layer for advanced firewalls. So what other kind of things it do? Like yeah, first of all, it do the packet inspections, means it analyzes the data packet based on the IP address, port, and protocols. Then rules-based filtering, means it allows or block the traffic based on the security policies. Then deep packet inspecting or inspections, means advanced firewall inspect packet content to detect the threats. And then logging and monitoring, means it tracks the network activity and logs suspicious events. And also it tries to help with intrusion prevention, means detect and block the cyber attack in real time. Now the types of firewall, but before this let me give you some important firewalls. Yeah, this notes. So this is for the extra studies. Now types of firewall. First, packet filtering firewall. Means either it works with layer 3 and layer 4 and allows or block the packet based on IP port and protocol. Example, access control list. And it comes with some limitations. I cannot inspect a deep packet content. Second is stateful inspections firewall. Means it tracks the state of active connections and allows the traffic only for established session and more secure than packet filtering, but requires more processing power. Then the third we have a proxy firewalls. Means it operates at layer 7 of the applications layer of OSI model and acts as an intermediary between users and the internet and hiding the internal IPs. Example is quiet proxy, but it can slow down the network performance. After this, we have the next generation firewalls. Means it combines the features of traditional firewalls, intrusion prevention system, and deep packet inspections. Even sometimes it also uses artificial intelligence, machine learning, threat intelligence for advanced protections. Example like Palo Alto. Now, next we have cloud-based firewall. Means hosted on the cloud instead of the physical hardware and protects the remote users and multi-cloud environment like Cloudflare firewall. And the last one is web application firewall. This one is very important to understand because it protects web applications from the threat like SQL injections, cross-site scripting. Means there are lots of different kind of attack which practically you will learn from myself. An example are AWS firewall and Cloudflare firewalls. Now, advantage of this firewall. So the first is it prevents unauthorized access. Means it blocks the malicious traffic and hackers. Also, it monitors the network traffic, means logs activities for security analysis. And then it protects against malware. Means some firewalls have built-in antivirus and anti-malware features. Then it enforces the security policies. Means it restricts the access based on the predefined rules and reduces network threats. Means it helps to mitigate DDoS attack, intrusions, and exploit. Now, if we talk about the disadvantages, so it can slow down the network speed and it is not a complete security solution, and it comes with a complex configuration and also costly. So where we use these things? We use these things in corporate network, like to protect the business data and user, on cloud security also, then data center, home network, and industry system like SCADA. But SCADA, I'll give you the different chapter details about these things. And now you can take the screenshot. Okay. So let's take a 10-minute break and then we'll continue with the rest of the chapter. Uh, in Google time. Yeah, thank you. Okay, so next we have this OSI model. But before this, let me give you firewall notes. Okay, yeah, OSI model. Now, OSI model. So this is known as Open System Interconnections model. And actually, this is a conceptual framework used to understand like how the different network protocols interact in a layered architecture. And it divides the network communications into the 7 layer where each layer has a specific function. Means this OSI layer is known as Open System Interconnections model. And this one is to understand and standardize the computing system without regard to its underlying internal structure and technologies. It was designed by the International Standard Organizations in 1976 and started implementing in 1986. Now, it comes with a 7 different OSI mod like physical, data link, network, transport, session, presentations, and applications. So the layer first, suppose if you are sending the things, then it will come from physical layer from your side. And then data, then network, transport, session, then presentations, then applications. So the main benefits of using this OSI model is the first standardizations. Means the OSI models provides a standardized framework for network communication and allowing a different system to communicate with each other. Second is modularity, means the OSI models breaks down the communications process into separate layer and making it easier to develop, test, and maintain the network protocol. Then flexibility, means the OSI model allows for the use of different protocols and technologies at each layer and making it easier to adapt to changing the network requirements. Now, let's start learning with the different layer. So first here, we'll talk about the physical layer. Okay. So as you know now, this is the first and the lower layer of this OSI model. And it is responsible for the actual transmissions of the raw binary data, means bits, over a physical medium. Physical mediums like cable, radio waves, etc. And this layer actually deals with the hardware component of the network. Means its main function is bit transmissions. Means it converts the digital data into electrical, optical, and radio signals for transmissions. Then media selection means it determines the transmissions medium, like the copper cables, optical fiber cables, then wireless cables. Then signal encoding means it converts the bits like one and zeros into signal, like electrical, light, and radio waves. Then topology, definition means it defines the network layer like bus, ring, star, and mesh. And also it helps in synchronizations, means ensures the sender and receiver are in synchronized for the data layer and the transfer. And also it controls the data rate control, means it specifies the speed of the data transmissions measured in bits per second. Now, devices which work under the physical layer are hubs, then repeaters, then cables, all these things. Now, the key features of this physical layer first is no data interpretations. Means it only works with the raw bits, not packet or any kind of frames. And it handles the physical network structures like star, ring, bus, mesh topologies. And it also do the error handling, means detect but does not correct the errors. And then bit synchronizations, means it ensures the sender and receiver operate at the same clock rate. Okay. So real example of this physical layer, like imagine you're making a phone call. So your voice is converted into electrical signals, means analog to digital, and the signals travels through cables or wireless transmissions like Wi-Fi, 4G, and 5G. And then the signals reach the receiver and the phone decodes the signals back into the sound. So in this example, the physical layer is responsible for transmitting the electric signals and using cables and radio waves to carry the data, and also ensuring the connection is stable for the communications. So in summary, physical layer is the foundations of the OSI model. It handles the raw data transmissions using the wire or wireless signals, and the devices like hub, repeater, modems operate at this layer, And security threats include jamming and cable damage. So all these things is about the physical layer. Now let's understand a different layer, which is the data link layer. Now, data link layer is the second layer of this OSI model, and it is responsible for framing, addressing, error detections, and reliable data transfer over a physical link between directly connected devices. And this layer ensures that the data is delivered to the correct device on a network segments. Means its main function is like the framing, means it encapsulates the network layer packets into frames for transmissions, then physical addressing, means it uses MAC address to identify the devices, then error detections, means it detects and sometimes correct the transmissions error, then flow control, means it ensures the sender does not overwhelm a receiver with too much data. And next we have MAC, means media access control, means it manages like how the multiple device share the same communications media. And LLC is known as logic link control, means it ensures the reliability and error handling in the communications. Okay, now let's take some example. Suppose you send an email over Wi-Fi. So your laptop gets your email data and encapsulate it into the frame. And now your router add your MAC address and send it over the network. From then, the router at the receiver's end extract the frames and forward it. So this ensures that the correct device gets email ad data before passing it to the network layer. Now, the next layer is network layer. Now, this network layer is the layer 3 of the OSI model, and it is responsible for logical addressing, layering, routing, packet forwarding across the different network. And this layer ensures that the data reaches the correct destinations by determining the best path for transmission. And if we talk about its function, then it will do like a logical addressing, means using IP address like IP version 4, IP version 6 to uniquely identify the devices. Then routing, means determine the best path for data transmissions across the multiple networks. Then packet forwarding, means it moves packet from source to destinations through the routers. And then fragmentation and reassembly, means it breaks the large packet into smaller fragments and reassembles them. And the last, error handling, means it detects and handles the packet loss or corruptions. Now, Some real world example. Suppose you enter www.google.com in your browser. So now your device requests Google IP address from a DNS server, and your router uses the base route to send your request to the Google server, and the response follow the base return path for your device, and your browser loads the Google homepage. So this process is possible only because of the network layer. So network layer handles routing, logical layering, means IP and packet forwarding. It works with the layer 3 switches, and this one is all about the network layer. After this, the next layer you can see, we have this transport layer. Now, what is this transport layer? It is the fourth layer of the OSI, and it is responsible for end-to-end communications, error detections, flow control, segmentations of the data. And it ensures the reliable or based effort delivery of the data between the devices. So its main function is like segmentation and reassembly. Means it breaks data into the smaller segment and reassembles them at the destinations. Then reliable and unreliable communication means it uses TCP or UDP for the data transfer. Then flow control means it prevents sender from overwhelming the receiver using the techniques like sliding windows protocol. It also handles the error control, means it detects and retransmits the lost or corrupted signals, and used for multiplexing and demultiplexing. Means it allowed the multiple applications to send and receive data simultaneously using the port number. Now, some important port numbers start with, but I'll teach you this part in our coming sessions. Leave this part. Okay. Now, this example, you can say this transport layer ensures end-to-end corrections, communications, error detections, and flow control and multiplexing. It uses TCP and UDP for the data transfer. It utilizes the port number to distinguish between the applications. And security risks include port scanning, DDoS attack, and sessions hijack. Now, the next we have this sessions layer. So session layer is very important layer, and this is the fifth layer of the OSI model. And the primary role is to establish, then maintain, manage, and terminate the connections. And it ensures the data exchange are organized and synchronized, especially in long running and multi-request processes. Means it do the multiple kind of activities like sessions, maintenance, means it creates the communications, session establishment means it creates a communication sessions between the two devices. Then session maintenance means it keeps the sessions active even if there are interruptions like the network congestions. Then synchronizations means it inserts the checkpoints in the data streams and allowing communications to resume from the last checkpoint if interrupted. Then dialog control means it manages whether the communication is half duplex or full duplex, means one directions at a time or both directions simultaneously. And it also helps in the sessions terminations, means gracefully ends communications and freeing up the resources. Now, devices and application using the sessions layer, like the web browser, where the track active sessions, then video conferencing means it manages the multiple media streams within a single session. Then file transfer application means resume uninterrupted download and upload. And then VoIP system means handles call setup, maintenance, and terminations. Now, the key features of this sessions layer is like it is so like if a file transfer or streaming session is interrupted, the sessions layer allows it to resume from the last checkpoint rather than restarting. Then dialog management means it determines the communication in one way or two-way, means full duplex. And sessions reconnections means it can automatically reconnect after temporary network failures. Some real world example, like when you log in into a website, the sessions layer tracks your authentications state. So you don't have to log in on every pages. And if the connections drop, it allow you to resume without losing the progress. Or some video streaming, like if your internet connection is interrupted, the session layer have the video resume from where it is stopped instead of restarting the entire stream. Now, the next layer. Next layer is, you can see here, presentations layer. Now, this presentation layer is the sixth and second last layer of the OSI model. And its main job role is to translate, encrypt, and compress the data so the different systems can communicate seamlessly. And it ensures the data sent by the applications layer of one system can be properly understood by the applications layer of another system. Means its main features is like translation, means it convert data format from one form to another. Then encryptions and decryption, means it secures data for transmissions like SSL, TLS encryptions for secure website. Then compression and decompression, means yeah, it reduces the size of data for faster transmissions like zip file, JPEG compressions like this. Now, applications using the presentation layer is, as I said earlier also, web browser, means it encrypt and decrypt the HTTPS traffic using the SSL and TLS. Then streaming services like Netflix, YouTube, Spotify, which use audio and video compressions like MP3, like this. Then email encryptions services means it secure email communications with protocol like PGP and file compression means WinRAR, 7-zip, gzip like this means it compresses a large file for storage and transmissions. Means the key features of this presentations layer is data formatting and encoding. Means it converts data into the format that can be understood by the receiving application, and it protects the sensitive informations during the transmissions and reduces the data size for faster and more efficient transmissions. Now, the last layer. So the last layer is about the applications layer. Means an application layer is the seventh layer of the OSI model, and it is responsible for providing the direct interactions between the user and the network by enabling the communications between the application. And this layer contains protocol and services that allow the user to send email, browse a website, transfer the file, and more. And the main function of this application layer is like the user interface support. Let me write the content. User interface support means it allows the applications to interact with the network like web browsing, email client. Next is network services means it provides a services like the file transfer, email communications, and remote access. Then the third is data exchange means it facilitates the communications between applications using the standard protocol. And then authentication and authorizations means it manages the user authentication and access control like the login credentials. So some real life example like a web browser means HTTP and HTTPS means when you visit a website, your browser uses HTTP or HTTPS to request and display the web pages. Then sending the email means SMTP, IMAP, POP3. So the email client like Gmail use this protocol to send or receive the email. Then file transfer means you might be heard about this FTP and SFTP means secure FTP means loading a website to a server using the FTP or transferring the sensitive file security using the SFTP. Then remote login means SSH connectivity, then Telnet connectivity like this. And then DNS resolution means trying google.com or typing google.com in a browser and the DNS resolve it to an IP address. And then network configurations. Configuration means automatically assigning an IP address when connecting to a Wi-Fi network. So in summary, you can say this application layer provides the direct interactions between user and network device. It includes protocol like HTTP, FTP, DNS. It supports the file transfer, web browsing, email communications, and remote access. And also, it works with the security measures like HTTPS, SSL TLS, and authentications mechanism to help to protect the application. So this one is all about the OSI models. So TCP IP model, you need to read to your own. So basically you will get only 4 different layer, and this is the latest kind of layer we use now. Okay, but OSI model is the oldest one now, but most important part, like the company ask you questions from the OSI model. So this TCP IP model stands for Transmissions Control Protocol and Internet Protocol. And it is also a network framework which is used to define like how the data is transmitted across the network, including the internet. And it is a simplified version of the OSI model consisting of the 4 layers which work together to enable the communications between the devices. Okay. So I'll give you the short descriptions with these things. The first is application layer. Means it directly interacts with the users and application. It supports the file transfer, web browsing, email and remote access. They use the protocol such as like HTTP, HTTPS, then email, then remote access like this. Then next we have this transport layer. It ensures the end-to-end type of communications between the devices. It uses TCP, means connections oriented, and UDP, connection less protocol for the data transfer. Then we have internet layer, which is equivalent to the OSI layer 3, and it handles the IP addressing, packet routing, and network traffic control. And it ensures that the data packets find the best path to reach their destinations. They use some protocol like the IP address, means it assigns the unique IP address and handles the routing. Then ICMP, which is known as Internet Control Message Protocol, which is used for the error reporting like ping command. And then ARP, known as Address Resolutions Protocol, means it converts IP address to MAC address. So example, when you visit a website, the internet layer ensures your data reaches the correct server using the IP routing. And the last layer is network access layer or interface layer. This is equivalent to the OSI layer 1 and 2, means it manages the physical transmissions of the data using the different network types like wired and wireless. And it also ensures the device-to-device data transfer using the MAC address. And they use some different kind of protocols. Like the first is Ethernet, means used for the LAN communications, then Wi-Fi for the wireless connections, and PPP for point-to-point protocol, means used in some dial-up connections, but now we don't use dial-up connections. Okay, so this one is all about this TCP/IP models. So you have this notes now. So tomorrow I'll take a small quizzes also, and you need to work according these things. And apart from this, network yeah, this is your assignment. So define the following routing devices and mention their primary function. This is the sections one. And which networking device helps in connecting the different network together. Second is the network topologies. So draw any or you can explain the 3 network topologies and which topology is best for large scale network and why. The section 3 is about area of network like LAN, MAN, and WAN. Give an example of each type of area in real life. And this one is optional. It up to you. If you want to do these things, it's okay. If not, then not mandatory. So last date is submission of this thing is 20th of February. Okay. So you all need to do these activities. And tomorrow I'll take your small cues. Yeah. And in our today's session, so in India it is 16th of Feb. We read about networking devices and OSI models. Okay. So anybody have any questions now?
No questions.
Okay, so I hope everything is clear from my side. But see, try to go with the entire notes. Try to give at least 1 hour of time with all this point. See, this is why I'm teaching you this point, because this one is very important to understand the things. And without this, no one can get to know like the real type example which we use these things. So this one is very mandatory and use. Okay.
Thank you.
Alright. Thank you.
Okay. Okay. So bye everyone. Take care. Have a nice day. Keep learning, keep practicing. Bye. Okay, Aurora, do you have any questions to ask? Aurora, are you there?